Lesson 27, two-column proofs. So there's 5 parts to a two-column proof, and we're going to list those 5 parts. The first one is that you want to have the given statement. So what information was given, and then you can list that out on the left side, and then the justification would just be given. Also, in the problem itself, there's going to be a prove statement. So they're going to say to you, this is given, prove that this, that, and the other thing. So it's called a prove statements, what you're trying to prove. So it's the statement indicating what is to be proved. Sometimes you'll have a diagram. So sometimes they will provide you a diagram. And that's usually some type of a sketch to summarize the information. If in the diagram you're shown that parts are congruent or angle measures, that's all going to be part of the given. You can include what's in the diagram as part of your given statement in the proof itself. The info. Sometimes you have to draw the diagram, which I highly recommend if they're giving you information that would be better understood in a picture. Number 4 are the statements that you're going to write on the left-hand side of your two-column proof. So it's the specific steps that are written in the left-hand column. And then the 5th and last step is the reasons. And the reasons that you can use are postulates, theorems, definitions, or properties. And you can't use made-up properties or definitions or theorems. They have to actually be ones that we've studied. And we write those in the right-hand column. So I'm going to do an example of a two-column proof and what it would look like. So we have given triangle ABC with exterior angles, angle 2, angle 4, and angle 6. Prove. So with this one there's actually going to be a sketch, so we'll draw that after I write what to prove, that the measure of angle 2 plus the measure of angle 4 plus the measure of angle 6 equals 360 degrees. So we're going to have this triangle that has exterior angles. We'll have 1, 2, 3. So we're going to have to come up with a plan. Whenever you have a proof, it's good to have a plan before you begin. Sometimes I never have a plan, I just start and then it comes to me as I go. But if you can kind of think through, what are we going to show here? We're going to be given that 2, 4, and 6 are exterior angles. We'll probably do something with maybe the exterior angle theorem that says the exterior angle is equal to the sum of the two remote interior angles. We might use something like that. Let's see. Let's begin with, I'm wondering if I have enough room. I'm just going to write small. So we have statements, reasons. We're going to leave more room for statements. Reasons don't take up as much room. Number 1 is we're going to write the given. So we have a triangle ABC with exterior angles, angle 2, angle 4, and angle 6. So if we use the exterior angle theorem that says the exterior angle is equal to the sum of the two remote interior angles, then we can say the measure of angle 2 equals the measure of angle 3 plus the measure of angle 5. The measure of angle 4 is going to equal the measure of angle 1 plus the measure of angle 5, and the measure of angle 6 is equal to 1 and 3 added together. Do you remember that?
Yep.
Exterior angle theorem. So we put right here, exterior angle theorem. Now what we're trying to prove is these three added together. So we can just add them together. Measure angle 1, let me show you. We have measure angle 2 plus measure angle 4 plus measure angle 6 equals, and then we can list out these three sums. So we have measure angle 1. Let's see, there's 2 1s, 2 3s, and 2 5s. So we can actually put a 2 out here. Measure angle 1 plus measure angle 3 plus measure angle 5. And that's called the addition of equations. So if you remember, if you had these three equations lined up, you can add them together. Do you know what I'm talking about when we add equations together? So you add the left side equals, you add the right side. So these are addition of equations. I think I'm going to run out of room. So we have a theorem that says that the three angles in a triangle, their measures add to 180. So we can say measure angle 1 plus measure angle 3 plus measure angle 5 equals 180 degrees. And that's called the triangle angle sum theorem. I feel like when I'm teaching this, it goes faster, mostly because I know what the theorems and definitions are. So the more you use them and the more you're naming them correctly, the more it will just come more quickly to you. So you do want to get really familiar with that. Yeah.
Now, sometimes would there be one or more than one reason or theorem or definition?
No, because if you're using more than one, you can split it up probably into 2 steps. Yeah, I don't think.
I'm saying like a different name though. Like would it usually be, it's like there's a right and a wrong, or is it just?
It depends on what step you're writing, I think. So, you know, if you put this step in, you could call it, no, because it's the addition of equations. trying to think if there's, cause sometimes there's, yeah, I think there's like two different that you can choose from, like there could be substitution or, can't remember what goes with substitution sometimes.
Yeah, okay.
But yeah, I've seen that before where it could be one or the other, or there's multiple ways to get the proof done, which I've seen before too with kids, and they're so creative with going through the proofs that it could be multiple ways. Okay, I'm just gonna turn the page here and finish out. So number 5, I am going to do substitution. The triangle angle sum theorem, so I'm gonna put a 180 right in those parentheses. So I'm gonna say measure angle 2 plus measure angle 4 plus measure angle 6. Equals 2 times 180 degrees, and that is substitution. And then the last step is to say that the sum of those 3 exterior angles, 2, 4, and 6, equals 360, and that's just to simplify. Which you can see, my final step looks just like what it said on the other page where it said prove this. So I got to that point by using postulates, theorems, definitions, and properties. So these would be considered properties. So I'm going to stop the lesson there.